In this tutorial, we'll learn how to composite V-Ray render passes using Fusion. This is the first Fusion tutorial from MographPlus, and there would be more. It's not about understanding V-Ray render elements and what each one represents what. You should already know that before watching this tutorial. This one is just going to be a fairly basic introduction to get you started in Fusion. So let's get started. Hey folks, welcome to MographPlus. Be sure to subscribe and ring the bell to get notified about our latest videos. Make sure to visit our website MographPlus.com or our Gumroad page at gumroad.com/MographPlus and check out our premium rendering and motion graphic courses for Cinema 4D, 3ds Max, Maya, Arnold, Corona, V-Ray, Maxwell, and so on. First, let's have a quick look at the scene setup in 3ds Max and V-Ray. I'm using this scene from Evermotion. I have just a few more models to get all the passes that I want, and the render settings were adjusted to achieve a linear render. If I go to the render setup window and open up render elements tab, we just have the most essential passes and some matte render elements in this tutorial, and maybe in another tutorial we can go more deep. In the frame buffer, we can take a look at some of these passes that we'll be using in a few moments inside of Fusion. Our essential passes to be able to recreate the beauty pass are lighting, global illumination, reflection, specular, refraction, and SSS2. To have a successful composite, we need mattes for our objects and materials in the scene, and thankfully V-Ray supports Cryptomatte. In the Render Elements tab, you notice we have 3 render elements based off of the V-Ray Cryptomatte render element, which you can simply add it using this Add button. I have added 3 and changed the ID type option to node name for the first one, node name with hierarchy for the second one, and node material name for the third one. If you go back to the frame buffer, you notice that the first creates mattes based upon node names, the second based upon node name considering the established hierarchy in the scene, and the last one create mattes based on the materials in the scene. So we have these Cryptomatte render elements in case we wanted to specifically adjust an object or a material inside Fusion. And honestly, having Cryptomatte makes other matte generators like multi-matte less relevant, as Cryptomatte is just much easier to set up and gives you everything you need. To save out mathematically and linearly correct render elements out of V-Ray, I always tend to use the V-Ray raw image file section under the V-Ray tab in the frame buffer section, and this is the best way to ensure you get a reliable and mathematically correct multi-layer EXR files. Just click on this browse button after enabling the V-Ray raw image file and change the format to OpenEXR. I have saved out this render as a 16-bit multi-layer EXR file, and honestly in most cases a 32-bit EXR file is an overkill, and a 16-bit EXR file is more than enough and will give you enough dynamic range to do whatever you want compositing wise. I will also provide this render for you to be able to follow along. Just click on the link in the description below. If you are planning on having a back to beauty composite in Fusion, you need to render in linear workflow. And V-Ray's default render settings assure that. Just make sure the color mapping is set to linear multiply or Reinhardt, and as you know, Reinhardt at its default state is the same as linear color mapping. If you are using Reinhardt, for example, and adjusted the burn value to compensate for blown out pixels, the render is no longer a linear render and you can't have a pixel to pixel accurate back to beauty composite within Fusion. I definitely advise you to check out our Ultimate Introduction to V-Ray for 3ds Max course. It's a 20-hour long course which goes through all of these concepts and more in detail. Now let's start compositing in Fusion. Fusion's default UI is fairly simple. The menu is up here. There are 2 image views where you can see any node that you specify. Here is the timeline. Nodes section down here is where you load images and work on them. And on the right side we have inspector panel where properties of selected nodes will appear to be modified. The first thing we need to do is to import our render into Fusion, and to do that we need a node called loader. From the tools menu you can access all the available nodes in Fusion, and loader node is within this IO section. A faster way to access this node is to right-click in the Nodes panel of the UI and use this Add Tools option. Now let's add a loader node, and our render is called ever49 final.exr. And if I click open, a new loader node with that exr file has been added to the flow. And if I select that node, you can see and adjust its properties from the inspector panel on the right side. Now, how can we see the render that we just loaded? As I mentioned before, we have these two viewers up here, and to see any node, we can just simply drag and drop it to any one of them. In this case, let's drag our node to the left viewer. Now we can see our render. To fit the render to the view, simply click on the viewer and press Ctrl F, or you can right click in this view and from the scale menu choose this scale to fit option. Before starting any composition, I tend to set the frame resolution and color depth of my composition. So from the file menu, choose preferences. You can adjust it globally or locally for the current composition that you are working with. I'm going to come down to the frame format for the current composition. The render we have is a 1000 by 1200 render. So change the width to 1000 pixel and height to 1200. As it's a single frame render, we don't care about frame rate in this comp. And finally change the color depth to 16-bit float. Now if you create a background or a gradient, all the nodes are going to be in sync and will be 1000 by 1200 and 16-bit. Even though Fusion is not resolution dependent and you can change the resolution and the color depth anywhere in the node chain, but it's a good practice to set your comp properly. Now the image we currently see is much darker compared to the render we saw in V-Ray Frame Buffer. The reason being is what we see is a linear image without any gamma correction applied to it. But what we saw in V-Ray Frame Buffer was a linear image with a 2.2 gamma correction applied to. And if we want to see the image in that sRGB color space, we need to apply that gamma correction. To do so, enable this LUT icon in the image view and open up its options. You can stick with this Fusion View LUT for now, and if you click on this edit button, you can set the color gamma to 2.2 from 1. And as you can see, we get our gamma corrected image back. I want to do the same thing for the right image view as well. I can drag and drop the image, or if you select any node and press 1 or 2 on your keyboard, it will load that image into the left or the right view. 1 for the left view and 2 for the right view. Control F to fit the image and enable LUT and change the color gamma to 2.2. Now we are ready to extract our passes and composite our beauty pass from scratch. So the question is, where are all the passes that we exported out from 3ds Max and V-Ray? Select the node and in the inspector panel, go to the Format tab and open up this channel section. Here you can define red, green, blue, and the alpha channels. By default, we have R for the red channel, G for the green, and B for the blue, and A for alpha. And this gives us the beauty pass. Let's start with the main lighting pass. I'm going to change the R channel to V-Ray Lighting R, G to V-Ray Lighting G, and blue to V-Ray Lighting B. And as the lighting pass doesn't have a specific alpha channel, we leave the alpha channel to come from the main alpha pass. Great. Now we have extracted the lighting pass out of our EXR file. Lighting pass in V-Ray is the same as diffuse direct pass in Arnold in case you are using Arnold as your render engine and exporting AOVs. If you click on any of the image views, you can press R, G, B, A, and C to switch between the red, green, blue, alpha, and color channels. Or you can use this drop-down menu up here to do the same thing. I'm going to select the node, right-click on it, and rename it to Lighting. And the hotkey to renaming is F2. Now let's get our GI pass. Simply select the current lighting pass, Control C, and Control V to make a copy. Now we can select the new node, press F2 and rename it to GI. And change the R, G, and B channels to V-Ray Global Illumination R, G, and B. Now that's our GI pass. Right now, both our image viewers are occupied with the lighting pass. Let's assign the GI pass to the right view. We can simply drag and drop the GI pass to the right view. Okay, so that's our GI pass. Right now, we only have 2 nodes. In bigger compositions, we can simply end up with tens of nodes, if not hundreds. So we need an indicator that tells us which node is currently assigned to the left or the right view. And that's what these white and black dots show below these 2 nodes. For this lighting node, which is currently assigned to the left view, the first dot is turned on. And for the GI node on the right view, the second dot is turned on. By the way, you can use 1 and 2 hotkey, as I mentioned, to display a node in the image views, 1 for the left view and 2 for the right view. Let's quickly get the other passes as well. I'm going to copy the GI pass, rename it to specular, and change the R, G, and B channels to respective specular channels. And press 2 to view this pass on the right view. I'm going to copy the specular pass and rename it to reflection, and change the red, green, and blue channels to respective reflection channels. And press 2 to view this pass on the right view. Next, we need refraction. Copy one of the existing nodes and rename it to refraction, and set the red, green, and blue channels accordingly. Leave the alpha channel as is and press 2 again to view the node. And finally, we need SSS. So do the same process as before. Copy one of the existing nodes, rename it to SSS, and set the red, green, and blue channels accordingly. And leave the alpha channel as is. Now press 2 again to view the node. Now we are done with our main passes. Obviously, it is a bit time consuming to extract these passes manually, and there are scripts for Fusion to automate the process, but that's how you do it manually. When working with bigger composition, having a tidy, organized flow is a good idea, and one of the ways to achieve that is to enable grid snapping for the nodes. Simply right-click in the flow, and from the Arrange Nodes menu, enable Snap to Grid option. And just quickly move the nodes around and organize them in a straight line. As we'll be starting to comp these passes together from left to right horizontally, we can put the first node a bit lower compared to the other nodes. Now if we add all of these passes together, we can get our original beauty pass back. Let's start with the lighting and the GI pass. And to combine passes in Fusion, we use a node called Channel Booleans. I'm going to right click in the flow, go to Tools, Colors, and here you have Channel Boolean node. You see this toolbar section below the timeline. Here you have access to some of the more frequently used nodes and tools. For example, there is the loader node. There are some color correction nodes, rectangle, and other masks. Here is the channel boolean node, merge node, transform node, and so on. That's really useful. For now, let's add a channel boolean node from the toolbar. You notice each node has a few colorful triangles and a gray square. The yellow and the green triangles are the inputs. Usually the yellow indicates the main input or the background input of a node, and most nodes have a yellow input, and some of them also have a green input which indicates the foreground. So the yellow and the green triangles are the inputs, the gray square is the output, and the blue triangle is the mask input for most nodes. If you hover over any of these, you can get a description down in the status bar. Let's start with the lighting and the GI pass. When reconstructing beauty passes, the order of the nodes doesn't really matter. So connect the output of the lighting node to the background input of the channel boolean node, and the output of the GI node to the foreground input of the channel booleans node. Now let's view the channel booleans in the right view. In the channel booleans property, set the operation to add, and now we have added the lighting and the GI pass. In this render, we don't have any visible background elements, so the alpha channel is completely white. But if we had some background elements, we had some grayscale data in our alpha channel, because currently the channel boolean node takes the alpha from the foreground input, we would have lost that data. So set the alpha in the channel boolean node to do nothing for most cases. It's a good idea to keep an eye on your alpha channel to make sure it goes as you want. I'm going to press C to enable RGB display in the viewer. Now let's add the specular pass. Simply copy the channel boolean node, set the combined lighting and GI pass, which is the previous channel boolean node, as the background input of the new channel boolean node, and set the specular pass as the foreground input, and press 2 to see the current channel boolean node. And because we have copied the channel boolean node, the operation is set to add and the alpha is set to do nothing, so we don't have anything else to do here. Now we need to repeat this last step for the rest of the nodes. Just copy and paste the channel boolean node, set the previous boolean node as the background input, and the new pass you want to add as the foreground input. Let's see the last node in the chain, which basically gives us the combined and reconstructed beauty pass. Let me disable grid snapping for now. Now let's make sure the reconstructed beauty pass matches perfectly with the original beauty pass. I'm going to just copy the lighting node, rename it to beauty, and in the inspector make sure red, green and blue channels are set to R, G and B accordingly, which gives us our beauty pass back. Now view this beauty pass in the left view and the last node in the chain in the right view. And you notice we have an exact match. Remember, if you have other elements in your V-Ray scene like self-illumination pass, you need to add them as well. If the beauty pass and the back to beauty composite did not match pixel perfectly in this phase, the reason most likely is that your image was not rendered in a linear workflow. Just get back to Max and V-Ray and assure the linearity of the render. Let's start with a basic color correction. I want to make the leaves a bit more vibrant, more saturated. We know most of the green colors of these leaves is coming from the SSS pass. The lighting and the GI pass also contribute to the color. And if we wanted to change the color, we probably needed to take all of these passes into consideration. Generally, as the SSS pass contributes the most for the color of these leaves, we can safely apply our color correction to just this pass. So let's add a color correction node. We can right click and from Add Tools menu and Color submenu add a color correction, or we can add it from the toolbar. Another way to add a node is to press Ctrl space and search for the node that you are looking for. So type in color corrector, and here it is. Each node has a shortcut as well. For the color corrector node is CC. So if I clear what I've typed before and just type in CC, we get the color correction node. Now click on Add or press Enter. Before inserting this color correction node after the SSS node, to disconnect the connection, simply click and drag it away, and that's it. To insert the color corrector node after the SSS node, simply hold down Shift, and if you hover over the connection, it turns to this green and blue line. And if you let go of the mouse and the Shift button, it has been inserted. And to remove a node from the chain, simply Shift drag it away. Let's view the SSS node in the left view and the new color corrector node in the right view. In the color corrector node, we can increase the saturation to 1.85 maybe. And voila, the leaves are more vibrant. And if we see the last node in the flow again to the left view, we can see the result better. To see how a specific node affects the whole composition, you can disable it. You can use this red button to enable and disable a node, and the hotkey is Ctrl-P. As you can see now, the leaves are more vibrant and really eye-catching. Next, I want to change the color of this rock to a nice bluish green color. Lighting and GI passes contribute the most to the overall color of this rock, and mostly lighting pass. So let's add a color corrector node after the lighting pass first. If you select a node by clicking on it and then add a color correction node from the control space menu or the toolbar here, the node will be automatically added after the selected node. Let's view the color correct node in the left view, and the last node in the chain in the right view. I'm just going to use this color to add a bit of bluish greenish tint to the rock. As you can see, the color correction adds this green tint to the entire image, and we want to restrict it to only the rock. And that's where the Cryptomatte that we exported from V-Ray comes into place. To be able to use Cryptomatte with Fusion, you need to install Cryptomatte plugin for Fusion. I'll be leaving a link in the description to where you can download and install Cryptomatte for Fusion. Let's start by copying any of the loader nodes that contain our original EXR render. Select a new node and go to the Format tab. Change the red, green, and blue channels to Cryptomatte node material name R, G, and B. And you can view it on the right view. And rename it to crypto_material name. If you select this node and press Ctrl space to add a Cryptomatte node, and see the result of the Cryptomatte node in the left view, this Cryptomatte node that we just added is basically what that plugin that I mentioned before will add to Fusion. Make sure to install that Cryptomatte plugin before actually starting the lesson. Now, the node has this red handle, and to select the rock, we need to move this handle on top of the rock. Press this Add button, and now the rock has been added to this matte list here. If I hold on Control and use my mouse wheel to zoom in, you can see the fringes of the rock are not selected yet, so move the handle over them and click on the Add button, and do that for both the upper and the lower fringes. Now we have properly selected the rock. And if I enable this matte only option, we get a perfect black and white mask. Let's see the color corrector node after the lighting pass in the right view. Now, how can we tell the color corrector node to use this mask and restrict the effect to only the rock? The blue triangle is where you connect your masks in Fusion. So connect the output of the Cryptomatte node to the mask input of the color correction. Now, this particular color correction node only affects the rock. As I mentioned, the GI pass also contributes the color of this rock. So how can we use the same color correction to affect the GI node as well? That's where we can utilize instancing. And this way, the parameters of these two nodes mutually affect each other. Let's see how it works. I'm going to Control C to copy the color correct node. Instead of a simple Control and V for paste, use Control Shift and V for paste instance function. You can actually right click and there's a paste instance there as well. And now, as you can see, there is a green line between the original color correct node and this new one, which indicates the instance nature of the relationship. And now any parameter adjustment in any of them will be copied to the corresponding parameter in the other one. So for example, if I set gain value to 2 in any of them, the other one will get that adjustment as well. I'm going to set it back to 1. Let's simply hold down Shift and insert the new one after the GI node and use the Cryptomatte node as the mask for this node as well. I'm going to just move these nodes around to have a better flow. Great. To keep the comp more organized, we can color code our nodes to be able to recognize them faster later on. In this case, let's select all the color corrector nodes and change the color of the nodes to a hot pink. And to do that, simply right click on them and from the set color menu, change the color to pink. We can select our Cryptomatte nodes and change the color to orange. And from now on, all the nodes that are used as masks can be orange. Now it's much easier to understand what each node does, especially if you work on a much bigger composition. Let's see the last node in the flow in the second view and think about the next thing we want to do with our comp. I don't want to make this video much longer, so let's finish it up. As one of the last thing, let's change this copper pot to a golden pot. The color of the pot is mostly coming from the reflection and the specular passes if you take a look at them. So first, let's create a mask for the pot using Cryptomatte. We can use the same Cryptomatte we use for the rock, so press Ctrl Space to add a Cryptomatte node and place it underneath the reflection and the specular passes. I'm going to connect the output of our loader node that contains the Cryptomatte pass from V-Ray to this input. Now view the Cryptomatte pass on the left view and the Cryptomatte node itself on the right view. Move the handle onto the pot and click on the Add button and enable matte only. Now add a color corrector after the reflection pass and set the Cryptomatte node as the mask for this color corrector node. I'm going to copy the node and paste instance it using Ctrl-Shift-V and hold on Shift and put it after the specular pass and connect the Cryptomatte node as its mask as well. Great. And set the hue value to 0.06. Let's make these color correct nodes pink and the new Cryptomatte orange. Now I want to add an overall color correction to the entire image. So add a new color correction node. You can use curves to color correct your image at any point, and there are other color correction nodes as well if you take a look at them. But let's use a simple color corrector node here and connect the last node in the chain to the input of the color correction node. I'm going to change its color to pink as well. And now because this color correction node has been applied after all the nodes, it will affect all the composition. The image lacks a bit of saturation, so let's increase the saturation to maybe something like 1.2. And finally, I want to add some contrast. There is a contrast parameter in the color corrector node, but it tends to clamp the values, and I tend to use a combination of gain and gamma to adjust the contrast. So let's increase the gain to around 1.3 and gamma to 0.91. Now that's much better. If you like what a node does, but you want to dial up or down its effect on your composition, you can go to the settings tab of that node and use this blend value to decrease or increase its effect. If I increase the blend value to 2, the effect of this color corrector node is much stronger, and if set to 0.5, the effect becomes half as strong as before. Let's set it back to 1 again. And you can tell a node to affect only a specific channel. So if we want this color correction node to only affect the blue channel, we can disable red and green channels. If I zoom out and take a look at the entire composition, I think I'm going to disable the 2 color correction nodes that made the pot golden. So just select them and press Ctrl P. I won't delete them. We can keep them in case we wanted to come back again. I think I'm done with this comp, but before calling it a day, I just want to show you one last thing, and that is how to use shape masks in Fusion. You notice in the toolbar we have a rectangle, an ellipse, a polygon, and B-spline masks. And if I right click and go to the tools menu and mask submenu, you notice we have other mask types as well, including bitmap mask, which can be very useful. Maybe we can add some vignetting and in the process use some of these masks. So let me add a background node. And this is the node to create solids or gradients within Fusion. We just want a simple black solid, and by default we get that from a background node, which is perfect. We can view this node in the left view, and to create that vignetting effect I need to multiply this black solid on top of the comp. We can use the channel boolean node, but there is a simpler node called merge. So let's add one. I'm going to use the last node of the comp as the background input and the black solid as the foreground input. Now in the merge node, using the apply mode, you can change the blending mode, and in this case we can use normal or multiply. It really doesn't matter. I just need to go to the blend tab and decrease the blend amount to 0.9. Now we want to limit the darkening effect to only the corners to create that vignetting effect. So we need a mask. And to add a mask, just select the background node itself and add a rectangle or a polygon mask. Let's go for a polygon mask. And as you can see, the mask will be hooked up to the mask input of the background node. Let's go for a polygon mask and create a loose mask by clicking around. And now in the mask properties, you can adjust the mask using parameters like soft edge, border width, and invert. And that's our vignetting effect. The comp looked nicer to me without vignetting, so let's use the last color correct node and disconnect the 3 nodes we use for vignetting from the comp, but keep them around in case. We can actually make a group out of them. Simply select all the 3 nodes, right click and choose group. You can double click on the group to open it up and rename it to something like vignetting, so we know what these nodes are responsible for. Perfect. Finally, we can compare our original beauty pass straight out of the renderer with the composition we built. Let's view the original beauty pass in the left view and the last node in the flow in the right view. Let me just pull down the timeline to make the image viewer bigger, or we can just disable this node section using this button up here. And press Ctrl F to fit both the views, and the color corrected image is looking much better compared to the original render. Currently we have this dual view, but we can turn it to a single view by clicking in this rectangle up here and click on the same button to go back to that dual view again. Let's get back the flow again, and the only thing that remains is to save the image out. I want you to remember that what we see as the final result has an LUT applied to it. So we are applying a 2.2 gamma correction to the image. We did that at the beginning of the lesson, if you remember correctly. And if I turn off the lookup table from using this button in the image viewer, this is the actual linear image that we have. You can save it out as it is and have a linear image if we wanted to, but in most cases we want to save it out as an sRGB image with a 2.2 gamma correction applied to. Now to save out the image you need a saver node, which is available in the toolbar as well. When you add a saver, first you need to define where you want to save the image and name the image as you wish. I tend to add a post suffix to my color corrected renders, and now press save. I'm going to connect the last node in the chain to the input of the saver node. In the saver properties, change the format to JPEG, for example, and make sure the .jpg extension has been added to the file name as well. And let's see the saver node in the left view. To get that sRGB image, go to the Export tab of the Saver node and open up the Output Gamma Space section. We don't want to keep this linear color space that we have, so keep to space and change the gamma space to sRGB and click on Apply Curve. Now we get a corrected sRGB image. Okay, in the timeline, make sure we only have one frame, and you can do so by zeroing out all of these timeline and render range values. And click on this render button and click on Start Render. And as it is just one frame, we get this render completed message quickly. And if we take a look at that output folder, we can see the results. Okay, we are done. Just save out your Fusion comp from the file menu and good luck. We barely scratched the surface, and if you want more Fusion tutorials, just like this video and leave a comment down below. Well, I hope you enjoyed this video. Make sure to visit our website MographPlus.com or our Gumroad page at gumroad.com/MographPlus and check out our premium rendering and motion graphic courses for Cinema 4D, 3ds Max, Maya, Arnold, Corona, V-Ray, Maxwell, and so on. Please like, share, and subscribe for more videos from MographPlus. See you next time.